Hello, everybody, and welcome to today's webinar, AI-driven test automation for modernizing the delivery of critical government applications. My name is Mark Lambert, and I'm joined by Product Manager for Parasol's Functional Testing Suite, Chris Colosimo. But before we go into deeper introductions, let's just do a little bit of Zoom housekeeping. Everybody's lines are muted, but if you have any questions or any comments that you want to enter into the system, there is a chat as well as a Q&A dialogue. We do have folks from the Parasol side sat on the channel here, so if you have any kind of issues during today's webinar, please feel free to send a message to the chat there. But quickly, if you just can raise your hands to confirm that you're able to hear me, you should see in the dialogue there. You should be able to raise your hand. Great, thank you very much. Okay, with that being said, we'll jump straight in. And today's webinar is being recorded and will be available after the session today for offline and on-demand viewing. My name is Mark Lambert. I'm the Vice President of Products here at Parasol. And I'm joined, as I said, by Chris Colosimo, who's our Product Manager for Functional Test Automation Products. So today, what we're going to do is we're going to talk about how we can apply test automation and specifically how we can apply AI to test automation to streamline the process of testing your modernized government applications. So to start with that, let's go ahead and move forward and talk about how we can build a scalable automation strategy. Many people within the Agile DevOps community really reference the testing pyramid. This is really a way of automating and, I'm sorry, it seems like my line is getting a little staticky. Chris, can you confirm that you're able to hear me okay?
I can hear you okay, but you are just a little staticky.
Okay, all right, I will try and manipulate things a little bit here, so sorry about that. Okay, so to ensure that we have a stable test automation strategy, we need to look at the blueprint for building that portfolio of tests, which is the testing pyramid. Testing pyramid does is it talks about how we should structure our portfolio of automated tests, starting with a foundation of unit tests and API tests, validating our business logic as close to the code as possible. Unit tests should be small, they should be isolated, and they should execute quickly. API tests gives us a great way of starting to validate integration of my systems and starting to validate business logic and business flow across underlying units. And then as we move up our testing pyramid, this is where we talk about testing through the UI and doing end-to-end testing of our application. Typically, you're going to be focusing on automated UI testing using something like Selenium, for example. And then obviously at the top of the testing pyramid, here we have manual testing. This is a pyramid, not a trapezoid. So each of these testing practices have value and are very important. Manual testing is arguably one of the most valuable parts of the testing process, but it's also one of the most expensive from the time, but also from human resource perspective. So if we're able to build a test automation strategy that helps us scale both from the point of view of time, effort, as well as the time that it takes to diagnose when you get a test failure and rapidness of feedback, then we can actually build a very viable continuous testing strategy to enable testing as an enabler for our modernization initiative rather than as a bottleneck in the process. But when we talk to many clients, most clients actually identify with a verted testing pyramid or an ice cream cone. Typically, many people start with testing through the UI layer because UIs are designed to be intuitive these days and often get stuck at that level. These are quicker to define, but they're much harder to maintain and much harder to automate. They're much harder to diagnose as well, and they take longer to run the higher they are up the testing pyramid. But the downside of moving down the pyramid is that they take more technical expertise. So the closer you get to the code, the closer you need the development team engaged, and the further away you get from the domain experts. So this is a challenge and a balancing act that you have to run through. And actually, when we dig into this a little bit more detail, we actually find that many organizations get stuck at that UI automation layer. And they get stuck for a couple of reasons. So the two things that we're going to focus on today is we're going to focus around the challenges that people have when you're talking about automated UI testing, which is the challenge of getting started with Selenium. And then the challenge of what they have when it comes to doing API testing, which is poorly documented or even undocumented APIs. So we're going to talk about these two today. We're going to talk about how we can really reduce the complexity of getting going with Selenium and how we can enable the testing of APIs through the use of exercising an application to understand how the APIs are really used, and also uncovering some of those undocumented APIs that often exist within application stacks. And we'll show you an example of that today. So let's go a little bit deeper into Selenium. Let's talk about that. So at Parasoft, we drive our product strategy through the use of data. Webinars like this will often run surveys, trade shows, client interviews, etc. And when we surveyed the industry about how organizations are testing their web UI, overwhelmingly, the number of organizations that are testing through the use of automation are leveraging Selenium. Interestingly, also, you'll notice here that there's 14% who are not doing any test automation today. They're just doing purely manual testing. Those folks right there have the challenge of how do I get going with test automation? And if I'm trying to go to Selenium, how do I enable my team? How do I reduce the technical complexities associated with Selenium? And how can I address some of those challenges that are going to stop me from scaling it? So that was actually the next question we asked in the survey was, what are your UI testing challenges? Now, creation is here. It's actually about 2/3 of the way down, 18% recording, writing initial test script. Well, you'll see that there's a whole bunch of other things that are testing challenges that typically grow in importance as organizations adopt their test automation strategies. So let's actually look at those. Let's break those down into kind of a list of 6. So these are the 6 things that this data basically boils down to. As I said, the first thing on the list is creation of the test scripts. But as you saw before, that wasn't number 1 on the list. That's because it usually is the first place that people start running into challenges. How do I get started? But while Selenium is code, and we're going to show you examples of Java code today, you're not building a full-blown application. You're getting going. You're using Java as a scripting language. So Java is very well understood. It's very well documented. There's a lot of online support around it. You're not building a fully complex application. So once you get going, that actually moves to the bottom of the list. Because what we find is, as you've got going and you've built your initial skills, other things propagate to the top of the list. And these are mostly orientated around maintenance. Maintenance of your testing script when the UI changes, maintenance of your testing script because your application is dynamic. It's either dynamic with element locators, how you identify the element on the page, or more importantly, weight conditions. A lot of websites today have dynamically loading content being loaded from back-end REST APIs, maybe changing the response times and the orders that elements appear on the page, and doing test automation around that becomes very difficult. Also, as I mentioned earlier, the higher you are up on the testing pyramid, the harder it is to actually debug and diagnose what's going on within your tests. So that was the next line of questions. So, or pain points. It's like getting access to the data. And as I'm at the top of the testing pyramid, is the amount of time that it takes those tests to run. Unit tests are small and quick. They run in isolation. You plug them right into your CI process. When you're talking about UI tests, you have to wait until the application has been deployed somewhere, and then you need to start running your functional scenarios, which going through the web requires the browser. So there's going to be an increase in challenges associated with the time that it takes to execute the test suites. Now, the good news is we have a solution for this. And this is where I'm going to hand over to my colleague, Chris. And Chris, show us how we can start to address some of these challenges with some of the Parasoft technology.
Awesome. Thanks, Mark. All right, so that's exactly what I'm going to show us today. I'm going to go through a couple of different demonstrations, essentially just starting from scratch. I'm going to have no tests. I'm going to go against a website, and then I'm going to create some easy to use Selenium tests, and I'm going to create some API tests and expose a very interesting thing on the website. And the website that I've chosen today, because we're talking military and government, is the FBI website, which is always fun to play on. The FBI website has a services section called the Uniform Crime Reporting Service that will show us crime statistics across any region that I choose. And it's a single page application that is loading a lot of its data from front-end REST APIs. So pretty modern architecture. Now, when it comes to testing a system like this, you want to make sure that you have good tests validating the UI, and you want to be able to build all those API tests against those front-end REST APIs. And so let me show you how the first part would be accomplished, which is building it against the UI. And so for that, let's go ahead and pull up the website. So here's the website, fbi.gov services. And if we scroll down here, the thing I'm going to be playing with today is the Crime Data Explorer. Now, ordinarily, I would say, well, let's go and do some manual exploration of this, but we can actually leverage that to create our UI and our API tests. And so for Parasoft, we provide a recorder, and that recorder allows us to record UI actions for our Parasoft Selenium product for creating Selenium tests, and at the same time, create and record and then create those API tests with our Parasoft SOA test solution. I'm going to do them both at the same time. So here, I'm going to go ahead and say start recording. Okay. So we're on this page. Let's go ahead and go into the Crime Explorer. And it's a pretty interesting application here. One of the challenges with a system like this is that it is constantly undergoing change. And so I'm going to show you how we can manage a lot of that change today. So here, let's go ahead and look at crime. And we'll look at crime in, how about Texas? Okay, and then we can click this go button. And then it'll go and give us some basic numbers up top. And then we can drill down to a specific type of crime. Let's just look at burglary. And we get these little charts that are filled with all sorts of great data. And then as we scroll down, there's a whole bunch of information. And all of this is actually being provided to the page via APIs. So I think that's a good recording for now. I'm going to go ahead and say stop. And I'm going to create my UI test first. So here's the Parasoft Selenium UI testing post-recording action. It's going to ask us for a name. So we'll call this Crime Explorer. I can give it a description or associate it with a requirement, which is important because I have requirements in my Jira system that I'm creating these tests against, and it'll embed that for traceability. I'll go ahead and say download recording. Now, this is going to be a little artifact that I can use to create a Selenium test. Now, here's our second panel. And remember, at the same time, we also created that API test. Now, when Parasoft goes and creates these API tests, it's going to use AI to look for patterns and relationships in those API calls. We'll drill into that in a second. For now, I'm just going to say, go ahead and create that test artifact. It's going to think for a second, and then it'll give me a little pop-up to let me know that that API test has been created. There we go. All right. Now, we'll deal with the API test in just a second. Let's go ahead and look into that UI test. So here today, I'm going to work in Eclipse. Parasoft Selenium is a plugin for both Eclipse and IntelliJ. That allows us to create these Selenium tests from scratch or merge into existing Selenium tests. So I'm going to go ahead and create one from scratch today. I'm just going to go ahead and say, let's create a Selenium test from recording. We'll call this FBI crime stats stats. I'll go ahead and point at my recording. I'm going to give it a package. We'll call this com FBI crime. And then the test is just going to be called test crime search. Great. And that's actually all I need to now create a pure Java Selenium test. Okay, so here's my Java Selenium test. You'll see here that I've created it in JUnit 5. We could also create them in TestNG if we like. It is a Java Selenium test with all the necessary importers and variables, everything assigned and ready for me to go. What's really powerful about this is I'm using something called the page object model. So the page object model allows me to define the pages on my application that I discovered as reusable objects in my script. And this is great because if I ever need to change something, like for example, I want to change the way that a locator works in one of these pages, I can just change it in that one spot, and if it will then propagate through the rest of my test. And it makes these tests highly maintainable. Plus they're code, so they easily integrate into my CI process. So now I'm going to go ahead and just right click on this and play this test back. The great thing about Parasoft Selenic is it makes Selenium less scary. Even for a novice Selenium user, it helps you build that foundation so that you can start wrapping yourself into a UI testing practice powered by Selenium. And Selenium is very universal. It can integrate with all of the other solutions that are out there. Okay, so that test played back, everything was great. Now, one of the things that Mark mentioned was, Selenium, it's great, people love it, but one of the major challenges with Selenium is maintainability. And what that means is that, here, even on our site, the FBI site was indicating, hey, we're undergoing change. And so let's go through a little example today. Let's say that on this site, when we went into the Crime Explorer, let's say that this button here, Go, is actually a recent change. Maybe recently, up until today, this button used to say search. And then they went and changed that button because Go is a little more relevant, it's a little hipper. Okay, what that would mean is that in our test, this element wouldn't say Go, it would say search. Now, it's a very small change, but this is going to break the Selenium test because there is no button called search. And this is where Parasoft Selenic becomes so powerful. What Parasoft Selenic does is it allows us to generate recommendations for failed locators and wait conditions as we're running our tests. And so essentially what that means is at runtime, which I'm going to do now, if there is a failure due to a moving locator, a stale element reference, maybe even a page that couldn't load in the proper amount of time, Parasoft Selenic is watching and it will provide recommendations back to us. So here, we're going to try to click on Go. We can't do it, and our test is going to fail. And it is going to take just a second because there's a timeout, but there we go. And then ordinarily at this point, you would say, well, I'm stuck. I don't exactly know where to go. But back here in the IDE, Selenic provides recommendations. There's actually a report. I just forgot to turn it on. We'll see that report in just a second when we play with self-healing. Those recommendations are AI powered. And basically what it says is, okay, you couldn't click on the search button, but we recommend, and we have 98% confidence, that if you change that element locator to this, you'll be able to proceed forward. And this confidence is a factor of weight and stability. Weight is different locators have different priority over time. And stability is, would this have executed previously in different versions? Because we want this test to run across all versions of our application. What makes this really powerful is that no matter where I am in my test, this can jump immediately to that line of code. That wasn't very exciting. Let's go ahead and jump right to that line of code. And then I can go and make those changes in my script. Now, this is great, but in order for this to have happened, I needed a test that failed. And maybe this go button is just one step in a much larger test script that I have. And this failed, and I never made it down to my other assertions. So let's do this. Let's go ahead and show how we can use AI to enable self-healing on pure Selenium Java tests. And that is a configuration here in Selenium that allows us to say, hey, don't just give me recommendations. Go ahead and try it out for me automatically. We'll go ahead and have it generate a report. And I'm going to do one other thing here, which is to report if execution time is larger than a prescribed threshold. So let's go ahead and see this in action. So what we're doing now is essentially we've broken our test. And so now we're going to see this run. And when it gets to that go button, excuse me, we're going to see that it will try to click on the appropriate link. It thinks, and it should move forward here. Oops, sorry. I think I had too many windows open at once. You missed all the magic. Let's do that one more time. Run. Okay. So here we're going to go. We hit that go button. Now notice in the bottom right-hand corner, the dialog is going to say that it is looking for a element locator. Okay. It can't find it. All right. And then it goes ahead and performs self-healing. So let's go ahead and look at that report. So here you can see that we had a test that failed, and it was healed with Parasoft Selenium's AI. Now, if we look at our screenshot, it'll actually tell us exactly where we were when we were trying to do that, clicking on that go button. And if we then click into this, we'll get a description of how the AI actually worked. It said, okay, I couldn't click on search, but I went back and I generated this new locator, go. I tried it and I was successful. It also provides us with a stack trace and details so that we can feel comfortable applying this to our test automation. Okay. Now, one other thing that's really important about this report is performance thresholds. So our test didn't fail. We were able to move forward because of the AI-powered self-healing. But we also are understanding that something's a little strange about this run. An execution time threshold was exceeded. So while Parasoft Selenium is collecting up information under the hood at runtime about how the web page looks, where the locators are, different timings on page, it's also timing the entire run of the Selenium test. And at this point, it said, you know, the historical average for this is 20.81 seconds. This test is taking longer than your threshold that you defined. And therefore, I'm going to give you a little warning because you might want to run a performance test on this. Think about this as the earliest stage performance test you could possibly run on the application. It's telling you that according to your thresholds, this page isn't performing correctly. Because if it's not working for one person, it's probably not going to work for 10,000 people. Now, all of this is being powered on top of pure Java Selenium. And this is one of the major differentiators here, is that it allows organizations to continue and comfortably adopt Selenium as a framework because there will be mechanisms to help safeguard maintenance by providing recommendations post-execution, as well as performance benchmarking to understand if anything's going crazy. So with that, I'll go back here into the presentation and I'll hand it over to Mark to talk us through what just happened.
Great, thanks, Chris. So, so Chris showed us quite a few things there, but the key thing that we're showing here is that, as Chris put it, we're making Selenium less scary. Okay, especially when somebody's first moving into test automation and is maybe not as comfortable with writing Java code. You need a jump start to that process, and that's what the recording of those tests gave us. So Chris showed us the recorder in the UI. He showed us that then taking the recording file and bringing that into the IDE and leveraging the page object model. This is, as Chris mentioned, this is an industry standard for making sure that you can build maintainable Selenium scripts, and it is in pure Java. So there's no Parasoft proprietary technology embedded within those test scripts and those page objects. I can then create multiple sequences, so I can record again and expand out my page object model, reusing elements, updating elements, adding new test scripts, and then these can be integrated directly into my CI/CD process. When they're integrated into the CI/CD process, this is where Parasoft Selenic kicks in again. So Parasoft Selenic here gives us the ability to be able to analyze those tests at runtime, and then we're able to self-heal when those tests fail and pass recommendations back into the IDE plugin to help streamline the updating of those tests. It's very key here that when Selenic is running the self-healing, it is not editing the script. You need to have a human in the loop to make sure that you're making the right changes to the test script and so that you have visibility as to what's going on as a whole. So these are the three key pieces of Selenic: the recorder, the IDE integration, and the command line execution. But in addition to that, we can also send the results of this command line execution to Parasoft's reporting and analytics dashboard, which gives us the ability to be able to correlate the test artifacts and the test results with the associated work items and user stories or test definitions that sit within my agile planning or requirements management system. So this gives me full visibility, not only from an individual test perspective, but as I said, it puts into context the business requirement and the user stories to give you visibility as to what the impact is of the testing failures to your core application. So the key elements that are within Parasoft Selenic, there are 5 key things to focus on. First, simplified test creation. This is where, as I mentioned, we're using the page object model. There's no vendor lock associated with it, and it's designed to plug right into your CI process. This is then when we are able to provide the AI-driven recommendations to provide feedback to the power users as to how to maintain or update those fix the tests. We can self-heal those at runtime, so we can reduce cycles associated with failed or unstable builds tests as part of your CI/CD pipeline. The reporting and traceability gives us not only that context with Jira, but also gives us an early warning on performance issues within the application. So this is where performance issues are going to surface. They're going to surface in your UI. And if you can get an early warning as part of your functional test automation that there's a potential performance issue appearing, this is going to give you a great jump start on making sure those issues don't appear. And then last but least, with something we didn't talk about yet, but hopefully we'll get time to talk about towards the end of today's session, smart test execution. So here is where, as you move further up the testing pyramid, we start to run into long execution times. And by leveraging optimization and of the test execution, we can actually trim down the subset of tests that need to be executed as part of your CI/CD pipeline. Now, we'll talk about that in a few moments as well towards the end of today's session, if we have time. But the key thing here is to optimize the feedback loop from your CI/CD pipeline. Okay, so let's kind of move further up the stack though. So we're also down the stack, should I say. So we've talked about the UI, but I kind of emphasized earlier that the APIs are a really critical part of your testing strategy. And certainly what testing at the API level is easier to automate, it's quicker to execute, but it has complexities associated with the test creation. So there are definite pros associated with the API testing, but there are cons also associated with testing at the API level. Requires knowledge of how those APIs are used. Often you'll actually, should I say, if you're lucky, you will get a description file that describes what the APIs do in individual atomic transactions. So things like a Swagger document or an OpenAPI document would describe how your REST APIs behave, but it doesn't describe how they are used. It doesn't describe how you chain these APIs together into a business flow. You only really know that by looking at the application and understanding the context of that. The challenge is that this is one of those things that falls into a no man's land. The development team feel that they have delivered everything that they need to because they've delivered the open API doc or the Swagger doc. Here, I've got APIs, it's documented, go ahead and do it. And then the testers go, well, I don't know how the API is supposed to be used, so I'll test individual siloed API calls, but I don't have the ability to test the actual usage. So if we dig further into some of the things that Parasoft SOA test gives us the ability to do, which is Parasoft's API testing technology, there are 4 key areas where we focus our API testing technology. Test creation, and test creation by not only looking at the descriptions of the APIs, but looking at how they're going to be used. We also have breadth of protocol support, so going beyond RESTful APIs and web services, things over HTTP, and really touching a whole variety of different back-end mainframe or internal systems as well. So everything from ESBs, MQ protocols, all the way through to microservices and things like Kafka as well. We also have a very broad ecosystem. So we're going to show you today how we can do rapid test creation, and we're going to show you that by interacting with the desktop client within the IDE, but there's also a web layer or a thin client interface that allows me to be able to manipulate my test environment and also build test artifacts within a thin client or within a browser-based ecosystem. And then last but not least, change. When your APIs are delivered, they are going to be updated in the future. So as you start to build your automation suite that is validating your APIs, you're going to need to maintain that test automation suite over time as well. So as those APIs change, you need a process that can really help you with the efforts of refactoring your test suites. So we're going to talk about 2 things here because today's conversation is specifically around AI. So we're going to talk about how we can use AI for rapid test creation. We're also going to talk about how we can use the AI to build in workflows that help you mitigate the changes of your underlying APIs. So with this, Chris, I'm going to transition over to you now and talk a little bit about how we're going to create those APIs and kind of put that in juxtaposition versus traditional design-based approaches.
100%. Thanks, Mark. So yeah, this is where things start getting really interesting, is all of those underlying API calls. Now, as Mark articulated earlier, this is a gap in our testing strategy when it comes to the test pyramid. And it is a little bit of no man's land, trying to identify whose job it is and how to get the best coverage. Now, traditional methods involve splitting this into integration and component testing, and then attacking it from the bottom. You get a Swagger, you get a WSDL, you load that into your testing tool, or you use it from the Swagger doc in your browser. And you look at the individual API calls and you say, okay, I guess I need this to go and try to get the crime stat. And then there's probably a token that I need for a session to hand it back to then get that for Texas. And it's really hard for the API testers to stitch all that stuff together and to figure out what the right sequence of calls are. So this is where we can leverage AI to actually create those API tests from the manual interactions with the browser, because the browser is using those front-end APIs. And you can then see how your system not only uses the APIs, what APIs and what data is exchanged, but you can also see them as a part of an integrated system. So that's what I'm going to demonstrate to you today. So when I recorded those browser interactions, I also recorded those front-end REST API calls. And we saw a little pop-up, and those were essentially being delivered to Parasoft SOA test. So here's Parasoft SOA test. It's an API testing solution that sports over 150 message formats and protocols and goes way beyond basic. Here, let's see, it would have delivered the test here to me. My name is Chris, and there it is. So let's go ahead and open the box and see what's inside. Okay, so that represents all the APIs that were called as I was interacting with that front-end web page. And we can kind of see it here. It's calling proxy API within the time period, Texas. So this is really cool because if I didn't know anything about this API, suddenly I know the sequence of events to accomplish the thing I just did in the UI. And if I run this, I'm going to have a really high degree of confidence that this is going to execute successfully. Why? Because Parasoft is using AI to inject all sorts of smart tools into the sequence. As I said, it looks for patterns and relationships, and it stitches those different pieces together to manage things like authentication, dynamic data exchange, and so on. From here, I could then go to one of my individual test cake calls. Here's one for the individual years. Let's go ahead and just look at the traffic object here. So here's the request that was made. And go ahead and get API estimates. It's got all the different headers and everything. And then we got our response object back, which we could then look as a literal or something nice and pretty that we could then immediately create regression controls to ensure that from an API perspective, we're running. Now we can train this AI too. It does a lot out of the box. But if we ever say make a change to something, like let's just say add a regression control, maybe an assertion on this, we've now done something different with this API. We could then train the underlying AI model to say, hey, look, if you ever see that again, I want you to add this assertion, and I want the assertion to have this value. And the net here is the more and more you use it, the smarter and smarter and smarter it becomes, and the more customized to your business. Now, there's also something kind of interesting that we discovered here, and that is that if you actually go to the Crime Explorer API doc, it says, okay, what you need before you start using our API doc is you need an API key. Okay, and then you sign up and you get this API key, and then when it comes to actually using any of these API calls, you can just try it here in the thing, but unless you have your API key, you can't be successful. But that's not actually what was happening from the front end. You see, when we recorded our tests, we noticed that there's actually a proxy service in between those front end REST APIs and the browser. And the reason that this was implemented was because the developer didn't want to have to potentially negotiate an API key every single time from the browser. And so they created a hidden API, and we'll see it here. Proxy. And if you look at these calls, they're not using an API key. And so the interesting part about this, if we look at the request header, no API key. The interesting part about this is that actually there are two APIs. There's the one publicly documented API that is probably being validated by QA. And then there's this whole other API that essentially is just routing information through. Maybe it's doing something special, but it's these undocumented or hidden APIs that can prove problematic when we're testing our application. For the Smart API Test Generator, it doesn't matter. It catches what is being called from the front end to the service and gives you a nice explanation of what those different calls are and allows you to get confidence in testing that service. Now, this can not only be done through manual interactions in the browser, so you can create it simultaneously with your Selenium tests to create those API test scenarios. But what if you have existing Selenium tests? Well, in Parasoft Selenic, we have an option, and you might have noticed it as I was working through the system, that any Selenium tests that we have, you can just go ahead and create an API, a set of API tests for that. And again, this is really powerful because you can then create a whole bunch of, let me close this, don't save. You can create a whole bunch of API tests to cover those UI test scenarios. And in a lot of cases, reduce some of those UI tests because you can just deal directly with the APIs and the data. Not only are those more stable because APIs change less than UIs, but you can also drive those with data and run them much, much faster, and also leverage them for performance testing. Now, there's one last thing that I want to talk about, and it has to do with change. You see, all of this falls apart if we don't have a good change management process in place. Now, I was on a deployment recently where I was working with Care First as they were implementing some healthcare.gov functionality into their patient portal. One of the things that they had was an integration with a third-party service. And what would happen is that this third-party service, which provided details about patients not in their network, it would change. They would basically send them an email and they would say, hey, version 2.6 is coming out and it's going to have these changes. And they'd send them a WSDL, but what are you going to do with that, right? You have to build something into your system and then try to figure out what the difference between the WSDLs are. You can do it, but it's really complicated. What they would do instead is they would say, you know what? We can't develop against this service for 2 to 6 weeks until those changes are live, and then we can run our regression suites and see what broke, right? Probably not the most efficient thing in the world, but that's probably what we're all doing today. Instead, we helped them use Parasoft's Change Advisor, which is an AI-powered change management solution that can watch different versions of the service definition proactively and look for change. When it sees change, it can build a model, or excuse me, it can build a template or a map mapping the 2 versions of the API to each other. You can use that to then update your API tests. So an example of that here, back inside SOA test, is if I were to go and look in my change stack here, I would see, okay, there's a whole bunch of services that are currently in use. Here's one where we see that there's a version change that's taking place. And if I go and I look at this version change map, I can see all sorts of things. I can see that we still have the same number of services, but some of them are changing name. And if I drill down even deeper, I can see that when it comes to the schemas, things are changing order. There's new elements that are being added. You can see that the AI is trying to make probability matches for existing elements. But then you can come in and say, well, you know what? Actually, price is not genre. So let's go ahead and disconnect that. And then make connections to what might be the way that this API has changed. You see the majority of the work's actually been done for you. And then once you're done with that, maybe configure a default value, connect it to a data source, put some random number generation and new elements that show up. You can then use that back in your API test library to identify and then bulk refactor any API tests affected. And that allows you to instantaneously change or update from that. So that in combination with our UI testing self-healing allows you to manage change from both the API and the UI test perspective. And so I think I'm going to hand it back to Mark to help us stitch all these solutions together. Mark?
Thanks, Chris. Thank you. So we showed you a few different pieces today, and these are pieces of the overall Parasoft portfolio. We have really infused AI into every layer of the testing pyramid, and this is represented by our portfolio of products. So if we actually look at the testing pyramid and kind of roll in the technologies that we talked about today, as well as some technologies that we didn't talk about today. So first, talking about the bottom of the testing pyramid, this isn't where we focus today's conversation, but this is where Parasoft's technology is designed to not only address that lowest layer, which is the unit testing, but also designed to streamline the application of code analysis techniques to uncover deep reliability and security issues within your application. This is where we've infused AI into the process of learning how the development teams work and using that learning to drive higher levels of code coverage, as well as drive improvements around the use of static code analysis within your DevSecOps pipelines. As you move up the pyramid, this is where we started to talk about Parasoft SOA Test. Parasoft SOA Test has obviously the core capabilities you would expect from any API testing solution that gives you the ability to create an API test from looking at a description. But the key thing is how we can leverage AI and machine learning to create API test scenarios by monitoring the interactions of your application or your test scripts with those back-end APIs. The API testing really is a part of your testing solution that you need to focus on, because this not only gives you a very effective and efficient way of testing business logic, both from a time but also a complexity perspective. But it also gives you the sweet spot for performance testing. Here you can scale performance testing and shift it left to earlier in your software development process by seamlessly reusing those functional API tests and pushing load at your application through the API level with removing the requirements for convoluted, complex web browser-based infrastructure. Now, web browser validation or validation of the UI is still a key critical component, and as we go to the top of the testing pyramid, this is where Parasoft Selenic plugs in. Key things about Parasoft Selenic is not only does it obviously use AI and machine learning to predict how you need to change your tests to maintain them, but also gives you the ability to create pure Selenium-driven tests. These Selenium tests are written in pure Java code. We're not locking you into a proprietary platform. It's not providing a Selenium-powered solution. It is Selenium. This means that you can seamlessly take advantage of all of the other tooling that's out there to support Selenium. You can stay within the standard IDEs. You don't have to adopt a proprietary IDE framework or a proprietary execution platform. And then, last but not least, service virtualization. We really didn't touch upon this today, but service virtualization is one of the keys for unlocking shift-left performance testing. Service virtualization allows me to simulate my dependent systems. No longer is an application one monolith that is self-contained. It in itself is going to be broken up into microservices. It's also going to have dependencies on other external systems. And for you to be able to test the components as well as the system as a whole, you need to be able to interleave simulations so you can get full control of your test environment. As I said, nowhere is this more important than when it comes to shift-left performance testing, because as you're trying to push load through your application and your part of the system, you're going to run into bottlenecks and constraints associated with the back-end systems. So this is the Parasoft portfolio. It's designed to help you deliver quality at speed. And Parasoft has been in the industry providing innovations in this space for over 30 years. So how do you find out some more information? This is where our team is available to help. As I said, we've been doing this for over 30 years. We have, as you can see, a very broad portfolio of testing products, and sometimes you want to know where to start. You're trying to evolve your testing practices. Maybe you've got some specific challenges. Maybe you're just trying to get into test automation to start with. Our team is here to help you with that, bringing our expertise from the 30 years, as well as our leadership in the market, to advise you as to what the best way to move forward is, with or without Parasoft technologies. We actually have a very broad partner ecosystem, and we do understand the broader vision. So I would request or offer up to contact our government solutions team. This is the email address for them directly. They'll be able to connect you with other peers in your industry space, as well as help advise appropriate next steps to take on your journey to full test automation. So with that being said, Chris, I think we have time for a couple of questions, and we've got a couple of here which I think would be really good to answer. And they're a mixture of technical and technical. So I'm just going to throw the first one at you here. It was specifically around the first thing we were showing, which was Parasoft Selenic. The question is, what about test NG? So obviously we were showing JUnit today. So what about testing? And could you compare and contrast test NG with the different JUnits as well as part of that answer?
Yeah, it's a really interesting time that we have when it comes to Selenium. We've got two sort of opposing armies right now that are really big on the JUnit 4, JUnit 5, and then on the other side of the house, you got the test NG guys. And I think they're both excellent solutions for Selenium testing. It's just in the way that those tests are put together. Now, when it comes to support for test NG, we do support the creation of test NG tests inside of Parasoft Selenic. Additionally, we also support the IntelliJ IDE. We tend to see those two go together. Now, when it comes to the difference between TestNG and JUnit, JUnit 4 was a test automation frame that was fairly ubiquitous in Selenium tests, but it lacked some of the parameterization capabilities that were required for running tests with multiple, across different data sets. TestNG sought to solve that problem by creating built-in mechanisms or built-in methods for easy parameterization. Some say it was also a little faster. Now, JUnit 5, which is relatively new, seeks to solve that problem and sort of bring the energy back into the JUnit side of the house by providing great methods for parameterization, as well as some different methods for assertions. And again, it's anytime you advance a framework, they look at what people are struggling with and add those new capabilities in. So I think it's sort of out there in debate. What's better, the TestNG or JUnit 5? Lots of people have strong opinions on it. It doesn't matter for us. We support them both.
Great, thank you, Chris. Another two questions here that I'm going to actually bring together, and I'll kind of answer these. Is this technology available on premise, or is it a SaaS solution? So the PowerSoft technologies are all designed to be deployed within your environments. We do a lot of work with defense government organizations where access to SaaS-based solutions or pure SaaS-based solutions is not a viable option. However, the PowerSoft stack is designed to run both on-premise as well as within your managed cloud. So whether that's public, private, or hybrid cloud ecosystems, it's designed to be deployed and executed within that environment. Now, the related question is, do you support Dockerization? So yes, the technologies can be containerized. They're designed so that they plug into Docker images seamlessly. And then our license management infrastructure takes care of handling which technology or which nodes in your cluster are being licensed and executed. Okay, and actually I've got another question here saying, what about smart test execution? So actually we do have time. Let's go ahead and show that one. Let's just touch upon that with one slide here, Chris. So at the end of all of this is you have a very broad set of tests, and these are going to take time to execute. So what's the best way that you can optimize your test execution so you can get as rapid feedback as possible? Well, here, this is where we have introduced technology called test impact analysis. What we do is we analyze what changes are actually going on within the code base. So and then we correlate that with the individual test executions. So as your test is being executed, we know what parts of the code base that test is touching. And then when we detect that those parts of the code have been changed, we're able to subset your test suite and only execute those tests which are required to validate those changes. This improves your overall velocity because as you're working through the development process in the day, you want to get quick feedback from your CI/CD pipeline. Then either overnight or as you get towards the end of your sprint, you're able to execute the more comprehensive test suite, but leveraging test impact analysis is going to focus your testing efforts and focus the feedback. We actually do this for 3 different parts of testing within the testing pyramid. We do this for unit testing, both in the IDE, so the developers can perform this test impact analysis prior to checking into the source control as well as part of the CI process. We can also do this at the API level. Here, what we're doing now is we're not analyzing the underlying code as you would get in the as part of the CI process, but we're looking at the binaries, the Java binaries that have been pushed through your pipeline. So we're doing fingerprinting of your jar files or your war files, and then we're using that fingerprinting to delta between 2 different builds and then optimize the test suites. And then that same practice applies for Selenium as well. So what this can do is it can turn your test suites at the higher level of the testing pyramid that may take an hour or so to run to just a handful of minutes, giving you much more rapid feedback from your functional test automation that goes in alignment with the test automation that you're getting from your unit testing. Okay, so with that being said, thank you very much for your time today. I think, hopefully this was useful for you guys. You can kind of see where you can infuse AI into the test automation process. And again, I would invite you to reach out to our government solutions team, who will be able to help you understand what the appropriate next step is to take in your journey towards high levels of test automation. So with that being said, thank you for your time. Chris, thank you very much for doing the bulk of today's work. And have a great rest of your day. And everybody, please be safe.